Okay, for this question, this is a complex numbers question. Okay, so it is given that z equals to this whole thing. So without using a calculator, now you're supposed to express z in this form. Okay, REI theta. So this is a pretty straightforward question. So first thing you can see that this and this gives you z equals to e to the power of I 3 pi over 16. So that's the first part. Plus, then the second part, e power I 7 pi over 16. Okay. So with this, what happens is that we want to make use of the property because they are of the same magnitude here. We want to make use of the property where e power I theta plus e to the power of negative I theta equals to 2 cosine theta. Okay, so we want to make use of this property. Okay, so because of the plus here, okay, if it's a minus, then it will be 2i sine theta. So because of that, you can see that for this part, right, the two angles are actually the same in magnitude, opposite in direction. So the way to do this, right, is to take out a certain factor so that you will get the same magnitude for both. And the factor that we take out will be 5 pi over 16. So how to get 5 pi over 16, right? Basically is to take this and this, you sum up, and then you take average. Okay, so 7 plus 3 is 10 divided by 2 is going to be 5. So e power I 5 pi over 16, open bracket, you're left with e power negative I 2 pi over 16 plus e power I 2 pi over 16. Okay, which is just make it simple, e power I 5 pi over 16, open bracket, so I put this one at the front, e power I pi over 8 plus e power negative I pi over 8. So your final answer is just e power I 5 pi over 16, open bracket, 2 cosine pi over 8. Okay, so this is the first part expressed in the form REI theta. So this is your R and this is your EI theta. Okay, so front part is done. Second part, find the smallest positive integer n so that z power n equals to k of minus 1 times minus I for some positive real number k. Now, to do this second part, okay, first we need to understand what is z power n. Okay, so the z power n basically is equals to just e power I 5n pi over 16, open bracket, 2 power n cosine power n pi over 8. Now this is equals to k minus 1 minus I. Okay, this is z power n, which is equals to k. If you do your quadrant thing, this is in the third quadrant, so you will get negative I pi over 4. Okay, so we cannot compare. Okay, basically what happens is that we want to compare your k here and here. This is the k. We also need to find the n. Okay, so once we can get n, we can get k, and k is just a positive real number. Okay, so it will always be positive here because what happens is that our cosine pi over 8 here is always greater than 0. It's in the first quadrant. Your 2 is always greater than 0. So as regardless of your value of n, it will always be positive. So what we need to do is to find the n. Okay, and what is that smallest positive integer n? Smallest possible. Okay, so what happens is that because this is actually sine, is actually still cosine pi over 4 plus I sine pi, minus I sine pi over 4. It's still related to cosine and sine. And cosine and sine is negative. Sorry, is periodic. Okay, so I can put it something like because sine and cosine are periodic functions. Okay, periodic functions with a cycle with a period of 2 pi. a period of 2 pi radians. Because of that, we can say that, therefore, I just change the color to blue. So therefore, your 5n pi over 16 must be equals to some form of minus pi over 4 plus 2, let's use capital A because we have k here already. Normally we use 2k pi, okay? So 2a pi, okay? Where a is an integer. A are all integers, so it's always possible. Okay? So what happens now is that, okay, let's make it simple. 5n pi equals to minus 4 pi plus 8a pi. So take out the pi, take out, so I will just let n make n the subject. I will be left with 4, open bracket. Oh, sorry, this one is not 8, this is 32, make a careless mistake. So 4, then after that, left with 8a, that's why I did this in the head too fast. Minus 1 over 5. So this is our n. And we want to make this an integer because n is the smallest positive integer. So here you can use your GC. Smaller. Maybe before that, maybe we can say, hey, for 8a minus 1 over 5 to be an integer, we want this as the smallest value. A equals to 2. Okay, how you can do this? You can just use, basically, you just use your GC. Y equals 8x minus 1 over 5. Then you do your second table. Okay, similar to statistics. So you get a GC table, and then after that you see when A equals to 1, 2, 3, then you find what is 8a minus 1 over 5. You'll see that this will give you an integer. Okay, so when a equals to 1, you actually get 7 over 5. It's not an integer, but when a equals to 2, we get 16 minus 1, which is 15 divided by 5, which is 3. So because of that, now we know that it's going to be 3. Your smallest n, okay, maybe I should put your smallest a. Okay, so the smallest n is equals to 4 times 8 2 minus 1 divided by 5. And this will give you 4 times 3, which is 12. That's the smallest value of n. Okay, but don't end there. The question did not say, the question say find the smallest. Yeah, okay, so that's the n. They did ask you to find k. So your final answer is just 12. Okay,